Now the unit number 2, kinematics. Let us take the important concepts. Particle kinematics. It is the branch of mechanics in which we study about the motion without considering the cause of motion. Here we are not saying what is making the particle to move. Next is the particle dynamics. It is the branch of mechanics. It deals with the motion as well as the reason. What is the cause of that motion? The next is object is said to be in motion if its position changes with respect to the surroundings. See, this motion can be explained with reference to a body that is at rest. This is the reason rest and motion are the relative terms. Next is the point object. If any object it has traveled more distance in comparison to its size, then that object is called as a point object. Next is the speed. It is the time rate of change of position of the particle. It is a scalar quantity. Velocity, if we have given direction to the body that is in speed, speed in particular direction is called the velocity. It is a vector quantity. Next is the average velocity. It is the ratio of the total displacement and the corresponding time interval for that displacement. The next is instantaneous velocity. Actually, it is a velocity at any particular instant of time, at any moment. So, it is the velocity of particle at any instant of time, or it can be at any point on the path. The both of them will mention as the instantaneous velocity. Next is the slope of the displacement time graph gives instantaneous velocity. To understand this, uh, look at this graph. This side we are having the displacement, and this is the time. So this is the displacement time graph. If the variation is a straight line, this refers to constant velocity, and any interval is taken of delta x and corresponding time is delta t. Then the average velocity is delta x by delta t, and this is also equal to the tan theta, that is the slope of the curve. In case if you want to take at any particular point, say at this position, let it be x dash, and for this particular x dash the time is say t dash, then x dash over t dash is again tan theta. It means that average velocity is equal to instantaneous velocity when we are talking about the motion of the body is such that it is moving with a constant velocity. If it is moving with a variable velocity, then instantaneous velocity will be different at every moment, and then it won't be equal to the average velocity. The next point is when a particle moves with constant velocity means there is no change in the speed and no change in the direction. The motion of the particle is said to be uniform motion. The next is the relative velocity. Suppose there are two bodies A and B, and we want to find out the rate at which one body changes its position with respect to B. That is mentioned as the relative velocity. This is given by VAB, and the magnitude of these two velocities get subtracted if both of them are moving in same direction, and if they are in opposite direction, then magnitude got added up. The next is 13th point. The time rate of change of velocity is called acceleration. The units are meter per second square, and it is a vector quantity. The slope of velocity time graph gives acceleration. The following are the equation of motion. It is kinematics because it is considering only the motion. It is not considering the cause of it, and it holds good for uniform acceleration. The first one is v is equal to u plus at. V is the final velocity, u is the initial velocity, a is the acceleration. S is equal to ut plus half at square. This is s is the distance, and rest other things we have discussed. V square minus u square is equal to 2as. S is equal to u plus v by 2 into t. Again, this is the formula for the distance. And if there are n number of intervals, then the distance in nth interval is given by u a by 2 into 2n minus 1. Now, the 16th point is that there is no quantity in physics that deals with the rate of change of acceleration. The next is, consider a particle which travels half the distance with velocity v1 and remaining half distance with velocity v2. Here v1 and v2 are the velocities, and the two halves of distance are being taken. In this case, the average velocity is given by this relation, uh, 2 divided by V average is equal to V1, 1 upon V1 plus 1 by V2. So here we see that average velocity is equal to the harmonic mean of individual velocities. Now, in the next one, consider a particle which travels half time with velocity v1 and the remaining half the time with velocity v2. In this case, we have taken two halves of distance. In this case, we are taking two halves of time, and v1 and the velocities are in those two halves. In this case, average velocity is given by v1 plus v2 by 2. It means average velocity is equal to arithmetic mean of individual velocities. The next is, while calculating displacement from velocity time graph. See here, the word displacement is being taken. Then we have to add up areas with due regard for positive and negative signs. Since displacement is a vector quantity, so its positive and negative sign are to be considered. While calculating displacement from velocity time graph, we use only positive sign. The 21st point is, if a particle covers one-third distance with speed v1, the second one-third distance with speed v2, and last one-third distance with speed v3. It means the distance is being divided into three intervals, and for those three intervals v1, v2 and v3 respectively are the velocities. Then the average velocity will be given by 3 v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. In the motion of a plane, there are the equations of motion under gravity. So here, when the body is moving under gravity, acceleration is replaced by g. Acceleration is replaced by acceleration due to gravity. V is equal to u plus gt. S is equal to ut plus half gt square v square minus u square equal to 2gs. For free fall, the initial velocity is 0. So keeping u equal to 0 here, we get v equal to gt, s is equal to half gt square, and v square equal to 2gs. Now, when the object is thrown in the upward direction, acceleration acts opposite to motion. In this case, we have to take minus g instead of plus g. At highest point, this is the final point, this is the maximum height it has reached. At here, the final velocity will become 0. So time taken to reach the highest point will be taking v equal to 0, and time will be given by initial velocity upon acceleration due to gravity. Maximum height is u square upon 2g. The time of flight, that is time taken to go up and come down, is given by capital T. It is equal to 2u by g. Consider a body that is starting from rest and moving with constant acceleration. The distances covered after first second and third second are in the ratio 1 is to 4 is to 9, and the distances covered in the first, second and third second are in the ratio 1 is to 3 is to 5. Make clear what are the words being used. It is covered after, and the ratio is 1 is to 4 is to 9, and the distances covered in the first, second and third second are 1 is to 3 is to 5. The next is about vectors. These are the physical quantities that possesses both magnitude and direction. But it is a must condition that vectors are those which obey the laws of vector addition. You can't simply add the vectors just like numbers. They will be added by the vector addition laws, and those are, for composition of two vectors, we may use either triangle law of vector addition or parallelogram law of vector addition. In case if the vectors are more than two vectors, then polygon law of vector addition is to be used. If we resolve a vector into its rectangular components, then we can write down sum of this component is along x-axis, y-axis and z-axis. So it have been split up into those, and it can be written as ax is the x component of vector A with I cap showing the direction, plus ay j cap, az k cap, and if magnitude is to be found out of the vector, then it is equal to under root of ax square plus ay square plus az square. The 25th point about this is the dot product of two vectors is always a scalar quantity, and the condition for perpendicularity of two vectors is that the dot product should be 0. And in the case of cross product, the product is always a vector quantity, and if the cross product of two vectors is 0, it means they are parallel. So this is the property of parallel: cross product 0. Property of dot product, the vectors are perpendicular if dot product is 0. Collinear vectors are those which are acting either along the same line or they are lying along the parallel lines. Next is the unit vector. It is a vector having magnitude 1. It is used to denote the direction of a given vector. Vector A, it is constituting magnitude and the direction. So this can be written A magnitude into A cap, that is giving us the direction. And this, the magnitude is 1. So A cap is equal to A vector by its magnitude. So we are left with direction, that is A cap. I, J and K constitute the orthogonal triad of unit vectors. Orthogonal triad means a pair of perpendicular vectors. So I, J, K are the mutually perpendicular vectors. Co-initial vectors, whose initial point are same. Co means same and the initial starting point is same. Coterminous, the vectors that are commonly terminating on a single point. When a vector is added to its negative vector, we get 0. This is called null vector. That is A vector, the negative of the vector, and we will get 0, null vector. A vector which gives position of a point with reference to the origin of coordinate system is called position vector. We have taken any point, say A. Now this point, if taken in the coordinate and O is the origin of this, then the vector R is said to be the position vector. The next is a vector which gives position of point with reference to a point other than origin of the coordinate system. O is the origin of the coordinate system, and we have to mention the position with other than origin. So let B be another point, and the R2 is the position vector for B, and let this distance between B and A is delta R. So this is given by R2 minus R. So delta R is giving the position of point A and B but that is not including the point of origin. So r is called the displacement vector. The next is if two vectors are equal in magnitude and direction, they are called equal vectors. Next is if two vectors p and q, they are inclined at an angle theta, then the magnitude of resultant r is given by p square plus q square plus 2pq cos of angle between them, that is theta. If beta is the angle between the resultant and one of the vectors, say p, then tangent beta is given by the formula q sin theta upon p plus q cos theta. In case if this beta angle is between r and q, then the values of p and q will be interchanged in the formula. When two vectors act in the same direction, then the magnitude of resultant vector is equal to the sum of the magnitudes of the given vectors, and direction of resultant vector is same as the direction of the given vector. What does it mean? Let p and q are in, these are the vectors, are in same direction. Same direction means angle between them is 0. Then resultant r is equal to p square plus q square plus 2pq cos 0 degree. So this thing will come out p square plus q square plus 2pq or p plus q whole square under the root, or this thing is equal to p plus q. So what we found out, the resultant is equal to the sum of the vectors as it have been mentioned in this property, and the direction of r will be same as the direction in which either of these vectors are acting. When the two vectors of equal magnitude act at right angles to each other, then the magnitude of resultant is equal to root 2 times magnitude of either vector. Also the resultant acts midway between the vectors. It means this thing, if suppose p and p equal vectors acting at 90 degree perpendicular, then resultant is p square plus 2p square cos 90. Cos 90 is 0. So this thing comes out to be equal to p square plus p square under the root or root 2p. This is what it have been mentioned. It is root 2 times magnitude of either vector, and the resultant vector for this will be at 45 degree, that is the midway. The next is the properties of vector addition. It is commutative. Commutative is related to the order. It means a plus b is equal to b plus a. The next is associative. Associative is regarding the grouping of vectors. It means a vector plus b plus c vector in the bracket. This thing is equal to a vector plus b vector plus c vector. It is distributive. Distributive property means multiplication of a scalar quantity with the vector addition. Let a and b are the two vectors and lambda is a scalar quantity, then we can write it down like this. It will be getting multiplied and we get lambda a plus lambda. Polar vectors, or another name is true vectors. These vectors are associated with the linear or the directional effect. For example, linear velocity, linear momentum. So these are the true or the polar vectors. The next is axial vectors, pseudo vectors or rotational vectors. Here they are related with the linear. These are associated with the rotation about the axis, and the examples are angular velocity, angular momentum. These are its example for the axial, pseudo or rotational. Either of the name can be given to the vectors. The next is about the important properties of dot product. Dot product is commutative. A dot B is equal to B dot A. Dot product of vectors is 0 if they are perpendicular. Dot product is distributive. A dot B plus C can be written as A dot B plus A dot C. The dot product in terms of rectangular components, this thing have been resolved in the directions. Suppose A and B are resolved in the rectangular components, then ax plus ax bx plus ay by plus az bz, these are the rectangular components of the dot product of A and B. Another important properties of the cross product. Cross product A cross B is not equal to B cross A. It is not following the commutative law as the dot product is having. Actually, A cross B is equal to the negative of B cross A. So this is the fact. The magnitude of cross product of two perpendicular vectors is equal to the product of the magnitude of these vectors. If two vectors are represented both in magnitude as well as direction by the two adjacent sides of a parallelogram, then the cross product is equal to the magnitude of the area of the parallelogram. If two vectors are represented by the two sides of a triangle, then half of the magnitude of the cross product will give area of triangle. In this case, we have mentioned that the two adjacent sides of a parallelogram, then the area of that parallelogram. For triangle, we have to take half of the cross product for the area of a triangle. When we resolve it in the rectangular components, A cross B can be given by this relation. For solving this matrices, we will get the A cross B, that is equal to AY BZ minus AZ BY minus J cap AX BZ minus BX AZ plus K cap AX BY minus BX AY. A body which is in flight through the atmosphere but it is not being propelled by any fuel is called projectile. The path that is followed by the projectile is known as trajectory. The horizontal and vertical motion of this projectile only, they are independent of each other. Horizontal and vertical components are splitted and they are not depending on one another. This is called principle of physical independence of the motion. The horizontal motion of a projectile is uniform motion, while the vertical motion of the projectile is accelerated motion, and this accelerated motion is controlled by the force of gravity. When a projectile is thrown at an angle of 45 degree, it is going to cover the maximum horizontal range. Maximum horizontal range is at 45 degree angle of thrown. There are two angles of projection, theta and 90 degree minus theta, with the horizontal, for which the horizontal range is going to remain the same. Now the next point is about the equation of the trajectory for oblique projectile. This is given by y is equal to x tan theta minus g divided by 2u square cos square theta x square. The time of flight of an oblique projectile is given by, this is given by capital T. Capital T is equal to 2u sin theta by g. Time of ascent of oblique projectile is equal to the time of descent of the projectile, and half of this time period is equal to the time of ascent, and that is equal to the time of descent, that is equal to u sin theta by g. Maximum height or vertical range of oblique projectile is given by u square sin square theta upon 2g. The horizontal range of oblique projectile is u square sin 2 theta by g. Now, if the projectile is fired from inclined plane. Let alpha is the angle of inclination with the horizontal. Then for upward inclined plane, the time of flight is given by 2u sine theta minus alpha upon g cos alpha. And for the downward inclined plane, this minus is replaced by the plus alpha, rest everything will remain the same. Maximum range is given by u square g 1 plus sine alpha for the upward inclined plane, and for the downward this minus sign will come here. And the maximum height of the projectile from inclined plane is given by u square sine square theta minus alpha by 2g cos alpha. Now we are talking about the motion in a plane that is circular in nature. So uniform circular motion. Any object is said to be in a circular motion if it is moving with the constant speed along a circular path, but continuously the direction is changing. The displacement in this type of motion is uh, angular. Angle swept by the radius in a given time, it is measured in radians. Angular velocity, that is denoted by omega. This is the rate of change of angular displacement, and this is equal to d theta by dt for a small variation in the angle. And the unit of the angular velocity is radian per second. Angular acceleration denoted by alpha, it is the rate of change of angular velocity, and the unit is radian per second square. Next is the centripetal force. It is the force that is acting towards the center that keeps the object in a circular motion. So that type of force is having centripetal acceleration. Acceleration is also towards the center of the circle. Another important term is tangential velocity. Tangential velocity is the linear part of the velocity, linear velocity of the object moving in circular path. Then the time period, it is the time taken to complete one full revolution. And the frequency is the number of revolutions per second. Frequency nu is equal to 1 upon t. There is relation between some of the linear and the angular quantities. Linear velocity v, this is equal to r the radius into the angular velocity. Tangential acceleration at is equal to radius into angular acceleration. Centripetal acceleration, this is denoted by AC, this is equal to v square by r. V is the linear velocity, r is the radius, or it is also equal to r omega square, that is the angular velocity. Centripetal force is given by Fc, this is equal to mv square by r, or it is mr omega square. It is important to note this thing that in uniform circular motion, we will talk about speed, velocity and acceleration. Speed remains constant. Velocity changes. Its magnitude remain constant, but its direction changes. Velocity change is only because of the change in direction. And about acceleration, the direction of acceleration acts along the radius of path towards the center, and it changes continuously, but its magnitude remains constant. So magnitude, either we are talking about speed, about velocity or acceleration, it is going to remain the same, but the direction is keep on changing at every point in case of velocity as well as in acceleration, and that is the change of direction in acceleration is always along the radius of the path and towards the center of the circle. There is some additional information regarding this unit. The first one is the tensor. Tensor is basically a physical quantity that is neither vector nor scalar. Actually, it is not having any specified direction. It have different values in different directions, and the examples are moment of inertia and stress are the tensor. The second one is there are three vectors A, B and C that are represented in order and magnitude and direction by the sides of a triangle taken in the same order. Then A upon PQ is equal to B by QS is equal to C by SP. and this is the exterior angle alpha, beta and gamma. So A upon its opposite exterior angle is alpha. A upon sine alpha is equal to B by sine beta is equal to C by sine gamma. So this is the Lami's theorem.